Let me recap the linear regression or simple linear regression or whatever it may be. Linear regression. If you look into the linear regression, the properties of linear regression, the two variables. Here in the simple linear regression, how many variables are we considering? We are considering only two variables, x and y. X is which indicates about the independent variable, y which indicates about the dependent variable. The relationship between x and y are the linear. That means as one variable is increasing, other variable either increasing in directly proportion or decreasing in inversely proportion. So when can we say the two variables is a linear in nature? The relationship between the two variables would be a directly proportion or inversely proportion. Then we can say it is a linear relation. Or else the two variables should be continuous variable. The most important aspect which you are looking till now, the two variables, the relationship between the two variables should be a continuous in nature. Third point will be normally distributed. Fourth point will be variance of error is constant, and fifth point will be observations are independent. That is absolutely perfect. So let's do a one lab. Let's do a one lab again, and then after we'll discuss what are the consequences, all these things. Product sales is the one data set. We are importing the product sales data. We are importing the product sales data. In the product sales data, we have the two variables. We have the two variables with 467 observation. We have the two variables with 460 observation. So dim of product sale means what does it will get? Dim of product sales will give us the how many number of observation we have and how many number of variables. In the product sale, we have the 467 observation, along with we have the two variables. The two variables which are the age and birth. And what are the variable names? Two variable names. Names of product sale means it will give us the what are the column names we have. It will give us the two column names. Those are age and birth. Here, let's check the type. What is the type of age variable? What is the type of birth variable? Checking the type of each and every variable. Let's check the class of what is that data? Product sales $age. The age is a integer. Table of class of product sales $bought integer. Okay, both are the integer variable. Now, before we are going to build the linear regression model, we need to make sure does my two variables are continuous or not. Now let's check the table of bought. Table of products sold sales $bought. That means in the bought we have only two levels. In the bought we have the two levels, 0 and 1. 0 and 1. Here in this case, when I talk about the 0 and 1, only two levels in the variable. Does it mean it is in a continuous variable? Does it mean it is a continuous variable? No, it is not the continuous variable. Continuous variable. When we discuss about the description of the continuous variable, what does it mean? Continuous variable is also called as the interval level data. So it should be having the some range, some point to some point. Here, for example, 0 to 1, it can be assumed that 0 to 1 range. Then it could be the points 0.1 also will be there, 0.2 also will be there, 0.3. But can you see any kind of such facilities in this variable? What variable? No. So we cannot consider what variable as a continuous variable. Okay. Now, still assume that we have the two variables, bot and age. The business object we are going to use here, we would like to predict with respect to the age. We would like to predict with respect to the age whether customer will buy the product or not. 1 means customer is buying the product, 0 means customer is not buying the product. And make sure that let me discuss that later. Make sure that what is your predicting, what is your not predicting. Always in the most of the 99% of the cases, you are trying to predict always the one. Always the one. I will tell you the reason also. Here we have, as per the business problem, what we are going to do we have two variables, bot and age. With respect to the age, whether customer will buy the product or not, we need to predict that. For that purpose, we are going to use the simple linear regression. Here in this case, with respect to the age, we are trying to predict. So age will be a dependent variable or independent variable? Age will be an independent variable, because whatever you are trying to predict, that is the dependent variable. We are trying to predict whether the customer will buy the product or not buy the product. So other variable definitely is going to be an independent variable. So age is an independent variable, whereas the bot will be a dependent variable. So we are going to build the model now. So how do we build the model? What is the syntax of the linear regression? LM of the syntax of the linear regression will be, the syntax of the linear regression, LM dependent variable tilde independent variable tilde independent variable, comma, data is equal to whatever example I kept is a hair. Depends on the data set, might change from point to point. LM of dependent variable tilde independent variable, comma, data is equal to 8. Okay. Here the same thing I am going to do here. Product sales model I am keeping as a product sales model is equal to, if you have doubt about that, we can write is equal to LM. LM is the linear model. Bot is our dependent variable, tilde age, comma, data is equal to product sale. Summary of, next step will be the summary. So if you look into the summary, what happens? So the minimum residual. So here call is the, as we discussed, the same thing. The call is the same thing which we are discussing daily. Residuals is nothing but those are the minimum value, first quarter, median value, third quarter, and maximum value. Residual is nothing but error. So error, what is the minimum error? What is the first quarter? First quarter is nothing but 25% of the data. Median is nothing but the middle point of the data. Third quarter is nothing but 75% of the data. Max value is nothing but maximum value of the data. Here we are looking for the coefficients. The coefficient same as like estimate. Estimate is nothing but intercept. The estimate is the beta naught coefficient minus 0.17. Age will be the 0.02. If I multiply the t value into standard error, you are going to get the estimated value. Here 49 into 0.0004, you are going to get the estimated value. So here 3 star, what does, which indicates 3 star, which indicates the significance of the 0.001, which indicates the double star, and 0.01 is the single star. Like that we have. Residual is the 17% and 19%, and 465. Why we got the 465? The formula is n minus k minus 1. N is nothing but total number of observations, that is 467, minus k is nothing but independent variable, minus 1. 1 is one dependent variable. So 467 minus 2, which indicates about the 465. And here r square is a multiple r square and adjusted, and f static value is this, and everyone is clear about it. Any questions about till now? I hope everyone is clear the process. Now we need to validate. We would like to validate whether we are going to do the correct results or not. As per the business definition what we discussed, we would like to predict whether with respect to the age, whether customer will buy the product or not. We would like to predict. That is the ultimate goal. So here we are trying to predict means whether customer is able to buy the product or not. That means can we able to tell in terms of the probability values only or in terms of the percentage value only. So if you look into very clearly, if you focus very clearly about the business definition with respect to the age, whether customer will buy the product or not buy the product. So first we need to make sure whether we are building a model for buying customers or not buying customer. Definitely now if you are building a model for the not buying customer, it doesn't make sense to us. So what we need to do, we always look for whether we are going to build a model for the buying customer. So we are going to get the probability values for the buying customers only. What is the ideal probability value? Ranges from 0 to 1, right? Is it possible to the probability values in the negative? No. Is it possible to have the probability values more than 100%? Not possible at all. Now let me go with a small example. New data, new underscore data, just I am creating, is equal to data.frame age is equal to 4. That means I am creating a new table. In the new table we are assigning age is equal to 4. That we are creating a new table with the name of new underscore data. New underscore data. So here if you may get the doubt, see here age is equal to 4. With respect to the when age is equal to 4, we would like to predict what is the probability whether customer will buy the product. So now let me go with the one example very clearly. Here the thing is that what is the equation? Y hat is equal to beta naught plus beta 1 x. Y hat is equal to beta naught is nothing but minus 0.1704 minus 0.1704 plus 0.025 into age only. X is nothing but independent variable. That is the, is it the equation? Is it the correct equation? Right. Now when we mention this one, we would like to predict now what is the y hat value. For example, age is equal to 4. What is the y value? Let's substitute this 4 value in this equation. So what happens? Minus 0.1704 plus 0.025 into 4 minus 0.1704 plus 0.025 into age, right? So simply we can write, how do we write? Minus 0.1704 plus 0.09 around the same only, around 9. So is it the positive value or negative value? Around minus 0.08. right, around 0.08. That means it clearly indicates that minus 8%, right? Minus 8%, 0. Let's convert them the value into the percentages. This value is the minus 8%. Now, does it make sense? Does it make sense? It does not make sense. The reason is that the probability value should be within the range from 0 to 1. Here we got the negative values. So in this case, does it make sense? No. Now you may get a one question. How do you think 4-year-old guy, 4-year-old kid will buy the product? He doesn't know anything. Basically, he don't know how to speak. How do you think 4-year-old guy buy the product? Okay, let's do with the 70-year-old guy. Let's do with the 80-year-old guy. Now, so everything whatever we are doing manually, we cannot do every time. We need to use the sum function. The function will be here. So we are using the predict. So yesterday also we use the predict. Predict means we'll get the predicting probability value. Product sale model. Product sale model means it will take the equation y hat is equal to beta naught plus beta 1 x. Here in the y hat, the beta naught means minus 0.17. Here you may get that. Where do you get the minus 0.17? This is the intercept estimation. Minus 0.174 is the intercept estimate. 0.02 is nothing but age estimation. So when we are checking the predicted value of this, predict of new data. New data means what is the value here? Age in the 4. What we get? Minus 0.08. Are we getting the manual also the same result? If you do the same thing manual also, we got the same results. Let's do. What is the you may get the 4-year kid. How do you think he may buy the product? It is not possible to buy the product. What about 60-year-old guy? Do you think he can able to buy the product? Definitely. He just retired from these officers. He definitely might have the product. Let's predict 60. So I am also storing in the same data is equal to the same way you can write is equal to data.frame age is equal to 60. Predict of this 1.08. 1.08, that is 108%. How does it make sense? Again, it is not make sense at all. Do we think are we doing the correct? Do we think are we doing the correct? Now let's draw a plot. Now whether we checking, we need to check the first point when we discuss about the linear regression. What we have discussed, the relationship between the two variables should be linear in nature. What do you mean by linear in nature? Linear in nature means either one variable is increasing, other variable might increase, or one variable is increasing, other variable might decrease. That means the relationship between the two variables will be a directly proportion or inversely proportion to each other. That is the meaning of the linear regression. So yesterday also, day before yesterday, we draw a plot, right? Plot means we just draw in the plot, and how do we check it? Here, how do we plot the data? Plot of product sale $age. Product sale $age means one variable. Always make sure that before the comma, plot of x comma y, first always we will write the independent variable before the comma, which is the independent variable, after the comma, which is the dependent variable in the plot. Here plot product sale $age. Let me write down, or else if you have a confusion about that. Plot of product sales $age, comma product sale $bought, comma COL is nothing but color. What color we are going? Are we going to give the blue color or red color? You can write red also. You can write yellow. You can write pink also. Anything will be 5. Let me write blue, which is my favorite color. Okay, what could be the x-axis? X lab is nothing but x-axis, that will be the age, comma, y lab is nothing but by or bot, you can keep. Now run this one. Figure margins too large. What happened? That one second, guys. Plot it should work. Figure margins too large. Plot not granny function. Error in plot.new. Why it is happening? It should work. Okay, let me just discuss this point only. Okay, in case okay, maybe some issue with the okay, see, okay, let me write down the step here. See, here age in the x-axis and bot in the y-axis. Here, see, if you look into this graph, what happens? Here some values, this is the in the y-axis. What are the bot? We have the only two levels, 0 and 1. Am I right? 0 and 1. We don't have any other values. Okay, perfect. Here some values which are 0, some other values which are the 1 and the age value. So now we draw the plot, whether it is a linear line or not linear. So AB line is the absolute line, product sale model, line width, color is equal to 5. See, AB line is nothing but absolute line. So we need to, absolute line is nothing but straight line. Linear regression which is a straight line. What we need to, based on the product sale model, line width is equal to 5 is nothing but width of the line. Suppose line width is equal to 5 is nothing but the width of the line is 5 line. Color is equal to LW is nothing but line width. Line width is equal to 5 means the width of the line is 5. Color is equal to red. Color is equal to red, or you can keep the blue or you can keep the yellow. If you have doubt also you can check it. Color is equal to red plus you can keep the pink. See, pink line. Maybe you can keep the blue also. Blue line. Okay. Now, how does it looks like by using the graph? Is it a linear line? Not right. The reason is that as one value is increasing, other value also. Is it happening the same? No, it is not the linear line. That means there is some issue with your dependent variable. Here in our case, dependent variable is not a continuous variable. Dependent variable is a binary variable. In the binary, we have the only two levels, 0 and 1. But ideally, if you are building the linear regression, you need to have both your dependent variable as well as your independent variable should be in continuous in nature. Should be in continuous nature. So, but it is not happening. So, there might be some issue with your dependent variable. The issue is also the variable dependent variable is a binary variable. It should not be the, it should be the continuous, but it is a binary variable. Any questions, guys? Is it clear what is the issue, what is happening with the binary cases? Any questions about that? Hello?
No doubt on.
Okay. Okay. Now, no doubt, right? So, now, from this point only, we are deriving the logistic regression. You may get the doubt, why don't we use, let me discuss the some theoretical part, some just a mathematical point. Why binary equation? Why we have discussed with an example, everyone is very clear. If you are any more enthusiast who want to learn what is happening in the background by using the formula, why it is not working, let me recall once more time about the assumptions or properties. The first property will be your data should be linear in nature, both variables are continuous in nature, so normally distributed, and variance of error is constant. Fourth point will be observations are independent. Now what is the formula? Y is equal to beta naught plus beta 1 x. Y means your dependent variable, x means independent beta naught and beta 1 are the coefficients. Beta naught and beta 1 are the coefficients. Am I right? Now we would like to check here. Here now we are saying, as per the rule, your dependent variable and independent variable should be continuous variable. But what we said, we have taken as an example dependent variable as 0 and 1, x, I mean your independent variable is continuous variable. Now in the case y, which consists of 0 comma 1, am I right? 0 comma 1. So let me keep this as an example. Let's take the 0 first. 0 is equal to beta naught plus beta 1 x, am I right? Beta 1 x. So what happens in this case? uh, Beta naught is equal to minus beta 1 x, right? So if I want, or simply beta 1 x is equal to minus beta naught. So as we said the definition of beta 1 and beta naught, beta 1 means on an average 1 unit change of your beta 1 coefficient, how much it is impacting on your dependent variable, right? As we discussed the meaning for the definition of the beta 1 and beta naught, beta 1 means on an average 1 unit change of your independent variable, how much it is impacting on your dependent variable, am I right? So here in this case, we do have any dependent variable, that is 0, we never consider the 0 value. So if 1 unit change of your independent variable, does it impact in the intercept, am I right? If you look into this equation, 1 unit change of your beta naught, is it impacting your intercept? Definitely, right? So ideal cases, does the intercept should be a constant or not constant? Intercept is the constant, it will never change. Does it obeying the rules of linear regression? It is not obeying the rules of the linear regression. So this is the one case we are explaining. So other case, the intercept value is the constant, am I right? So assume that your independent variable is 0, then y value should be your intercept value, right? So beta, assume that x is 0, that means 0 is equal to beta naught. So let me write down this formula. Y is equal to beta naught plus beta 1 x. What is the intercept meaning? when your independent variable is zero, what would be the when your independent variable is 0, the y-intercept value will be y-intercept value will be intercept, right? This is the meaning of intercept, right? This is the interpretation of the intercept. No, but in this case, what happens? Let's take the 0. We are taking beta naught, beta 1, x, right? So x will be the 0, right? Then beta naught will be 0. So always your intercept value will be the 0. How does it make sense? It doesn't make sense. So if someone asks you, it doesn't ask mostly, if someone asks in interview point of view, you can tell this answer why we cannot use the linear regression when we have the binary dependent variable. Binary means 0 and 1 case. Now, what is the alternative for this? What is the alternative for this? The alternative for this will be logistic regression. The alternative will be logistic. Let me draw the plot with whatever we draw the logistic. Why we mentioned logistic also I will tell you. 0, 0, 0, 0, 0. Here also we got the 0, 0, 0, 0, 0. Right? We draw the linear line. Right? How does it look like? See. Does it look like this? Does it look like this? So it means it looks like this. Can anyone guess what is the curve? The S-shaped curve? Does it look like the S-shaped curve, the graph? Right? So S means sigmoid function. S means sigmoid function. Based on this sigmoid function, the activation function or the thing which we are going to use, sigmoid, the logistic regression based on sigmoid function only, we are going based on the S shape. S means sigmoid curve. Based on sigmoid curve, we are going to use the logistic regression based on the sigmoid curve. Sigmoid function or curve, or both are the same, because as we got the graph, even if I have a doubt about this, even if you check here, you see here the value corresponding 0, the 0, 0, zeros are there. Here the value which is 0 and the value, and here also the 1 maximum value is the 1. It cannot be crossed more than 1. So if, does it look like exactly the S-shaped curve? So based on the S-shaped curve, we come up with the sigmoid function. Here, what is the equation for the logistic regression? While we are building the logistic regression, the equation will be probability of y by x. I will explain what is the meaning of exponential of beta naught plus beta 1x divided by 1 plus exponential of beta naught plus beta 1x. Here, what do you mean by P of y by x? P means probability, y by x. We have discussed the multiplication probability multiplication rule. So, what is the y by x means? X has already happened. What is the probability to get the y? What is the probability to get the y value? X has already happened. What is the probability to get the y value? What is the probability to get the y value? So here x means all the independent variables. So based on the x, we are finding the probability of the dependent variables. We are finding the probability of the dependent. Here exponential means exponential, beta naught means beta 1, and here, okay, let me tell you one more interesting fact. So if I go to the formula here, exponential of beta naught plus beta 1 x divided by exponential of beta naught beta 1 x. When we discussed about the multiple regression yesterday, we discussed the one point. We taken the three variables x1, x2, x3. Y is the one variable. What we need to check the relation, each and every independent variable with respect to the dependent variable should be in linear nature. What we have taken yesterday, we have taken as an example x1, x2, x3 and y value. So the first point in the linear regression will be your independent variable and dependent variable should be linear. x1y, we have taken x2y, we have taken x3y. If in case any of the case which is not linear, what we need to do, we need to transform the data. That means converting the non-linear function into a linear function. What are the different transformations we have? Log transformation, exponential transformation, square transformation, square root or cube root. Here exponential is also one kind of function which are converting the non-linear function into linear data. So exponential is a non-linear function. Am I right? Here, what is the equation? Y is equal to beta naught plus beta 1x. What is this equation? Linear regression? Linear equation only. So beta naught and beta 1x, these are the inputs to get the linear equation. Am I right? Beta naught, beta 1x, these are the inputs to get the linear equation. Am I right? Am I right? So we can say like this: exponential of beta naught plus beta 1x divided by 1 plus exponential of beta naught plus beta 1x. So simply we can say exponential is a non-linear function, beta naught and beta 1x are the linear inputs. So we can say non-linear function of linear inputs are called as logistic regression. Is it clear why I derived this equation? Is everyone is clear? Okay, any questions guys? Is it clear guys or not clear how I derived the equation?
Listen.
Giri, tell me.
Koti, this part is clear. Can you give me the one more time explanation about why we go for logistic? Some reason you told it.
The reason is that logistic, when we look into the graph here, the graph is the S-shaped curve. If you know, as I explained the graph, let me explain you the graph again. The graph is the here your age variable x-axis, as we have taken example, your bot. In the bot we have the two levels only in the y-axis, 0, 0, 0.5, 1, 0, 0, 0, 0. and here the one cases will be, we are building the linear regression. What happens? It will draw a line. It will not go more than ideal. So if you are building this, it look like a S-shaped curve. S-shape means sigmoid function or sigmoid curve or sigmoid function or curve. Sigmoid function is nothing but the variable is a logistic regression. So the formula is logistic. We are going to use. That is the reason. Is it clear? Agree?
Yes, Koti.
Yeah.
And you told something like beta not equal to b minus beta 1 x. That explanation I couldn't able to.
Yeah, that explanation what I said, if we go here as an example in the practical we do here, if I take the dependent variable as the reason why I explained that, why don't you use when your dependent variable is binary? In this case, why don't you use the linear regression? For that purpose, I have given as an example. In that case, what I given in the example we given as, if we consider when your dependent variable is binary, we are getting the probability values is not in the range. The ideal probability value which we need to get in the range of 0 to 1, but where we got as minus, sometimes we got in the minus, sometimes we got more than 1 which indicates 100%, more than 1. Ideally it doesn't make sense. For that purpose, we are not going to use the linear regression. Someone asked in interview point of view, someone asked, that doesn't happen generally. For that purpose, what we need to say, if we consider y is equal to beta naught and beta 1 x. X is your independent variable, y is your dependent variable. Here in this case, we are considering y as 0, 1, binary case. Here in this case, let's consider as 0, beta naught plus beta 1 x. So ideally the definition, as we discussed in the last session, meaning of beta naught and beta 1. Beta 1 is nothing but one unit change of your independent variable, how much it is impacting on your dependent variable. But whereas in this case, if I consider beta 1 x is equal to minus beta naught, here if I change the one unit change of my independent variable, it is not impacting my dependent variable, it is impacting the intercept. So ideally it should not happen. So in this case of kind of things, we cannot use the simple or linear regression. We need to go for some other method. As per the graph suggests that we need to use the S curve. S curve which indicates the sigmoid function. The range of sigmoid function is from minus 1 to plus 1. We are going to use the probabilities, the general probabilities are 0 to 1 only, but sigmoid function ranges from minus 1 to plus 1. Here we are going to use logistic regression. Is it clear, guys? So simply we can say logistic regression means non-linear function of linear inputs. Yes.
Clear, Koti. What is mean by 1 unit of change?
1 unit change of means, for example, for 1 unit change means, for example, if you add the one value, for example 0.5, what is the impact it is going to on your dependent variable? That is the meaning of 1 unit. For example, you change the 2. If I multiply the dependent variable with independent variable with the 2, what is the impacting on your dependent variable? Unit means 1 point basically. 1, 2, 3, 0.1, 0.2, like this is called as units. Magnitude is also called as a unit basically, simply. Magnitude is nothing but quantity. Any questions, guys? Anyone is not clear? Because one more, just want to intimate, in the industry, if you want to go for the next after machine learning, now of course we entered the machine learning, we are entering into the deep learning concept. Backend, we are going to use the logistic regression only, but we need to understand very clearly what is happening here. in interview point of view also, definitely they are going to ask you the question about the logistic regression. Most of the banking industry, they are pro with the logistic regression. Is it clear why we are using the logistic regression? Huh? Huh. Mathematical equation. The mathematical equation for the logistic is P of y by x is equal to exponential of beta naught plus beta 1x divided by 1 plus exponential of beta naught plus beta 1x. Here, this case, it is also called as a non-linear function of linear inputs, are called as logistic regression.
Non-linear function means that exponential depending on linear input depending on.
Here we are not finding the probability when zero, when it is, we are trying to, what is the probability when it is zero dependent variable, what is the probability? Here we are finding the probability values, we are finding the probability values when dependent variable is 0, depending dependent variable, dependent variable is 0. So simply we can say what is the probability value when dependent variable 0 or when dependent variable 1. Simply we can say what is the probability value when your dependent variable 0 or dependent variable is 0 or 1. So okay, your dependent variable is 0 or 1. Let me go back to the distributions now. Let me go back to the distribution. In the if you want to use the logistic regression, your dependent variable should be a binary variable. If you want to use the most important points, if you want to use logistic regression, your dependent variable if you want to use logistic regression, your dependent variable should be, if you want to use logistic regression, your dependent variable should be binary in nature. Binary means, okay, if you want to use the logistic regression, your dependent variable should be in binary nature. Okay, what do you mean by binary in nature? Binary means 0 1. Binary means 0 and 1. So that means, can we say true or false? Can we say success or failure? Or failure or success? 0 what? Okay. So what are the properties of binomial distribution? If we discuss the binomial distribution means the number of trials are number of trials are fixed. The first, if you remember, number of trials are fixed. That means here we can simply in logistic regression total number of rows. Total number of rows. Second point, two possible outcomes. Two possible outcomes. Here there are success or failure, 0, 1. Success or failure, true or case, yes or no. Here also in logistic regression, the dependent variable is true or false. Here success is denoted with the P, failure is denoted with the Q. That means P plus Q is equal to 1. One trial should be independent with the other trials. One trial should be independent with the other trials. So if you look into here very clearly, categorically it indicates that does the properties of binomial distribution, does it implicating or influencing the logistic regression? If you categorically if you look into that, your binomial distribution properties, does it influencing your logistic regression? Definitely. The property of number of trials are fixed. What does which indicate total number of rows. That means we are building the model, you need to have a minimum number of observation, and we are considering the 467 record. Two possible outcome. Our dependent variable also two possible outcome, 0 and 1. We can say that yes or no, true or false, success or failure. Total number of rows is always fixed, that's true. And one trial, so one row should not influence the other row. That is the property we are discussing. One observation is independent with the other observation. So all observations are independent. In the linear regression, we discuss the point. Observation should be independent. That means one trial should not influence the other trial. First row is the 0. There is no record. First row dependent variable 0. Is there any guarantee second row should be a 0? No, it can be 1 also, or it can be 0 also, but should not influence the first one. Alright? Does it exactly influence in the dependent? So now, how do we build the? Of course, before we are going, any questions, guys? Before we are going to discuss, do you guys have any questions? No? Okay. Thank you. Now, how do we build the logistic regression? The syntax will be, let me write down the syntax. Model 1 is equal to syntax of logistic regression. Syntax model 1 is equal to GLM. GLM means I will write generalized linear model of dependent variable bot tilde independent variable comma family is equal to binomial comma data is equal to data set name. Here family is equal to binomial. First let me discuss about the model 1. That means we are storing that information into the model 1. Here next will be GLM. GLM means generalized linear model. GLM means generalized linear model. generalized linear model. What is your dependent variable? And tilde is the nothing but equal kind of thing. Independent variables. Family is called binomial because the background which works for the binomial distribution. Data is equal to data set name. Whatever the data set, we are going to use it. This is the syntax of the logistic regression. Okay. GLM means generalized linear model. What is your dependent variable? Tilde independent variable, comma family is equal to binomial because we are using the background is a binomial. Data is equal to data set name. Let me run this one. Let me here see product sale logit model. GLM is equal to generalized linear model. Bot tilde age. Family is equal to binomial. Data is equal to product sale. Is it with the same we are writing? Now we are building this summary. See, let me go with the same. Here summary. How do we interact this one? See, the syntax will be the same. Product sale logit model. GLM is equal to bot tilde. What is the dependent variable? Tilde is the independent variable. Family is equal to binomial. Data is equal to your data set name. The data set is the product sales. Deviation results, which indicates about same your error. Deviation result means error, the same actual value minus predicted value. Now here coefficient means the same thing. Here coefficient means estimate is the beta naught, standard error means mu by sigma. Here z value which indicates the t value. Basically yesterday we got the t value, right? Z is equal to x minus mu. Here they kept as a z value. Probability is the 3 star like the same way. Here even if you multiply this one also, see, I will explain you this one thing. So first one is minus 9.497. Second one is the 0.7275. So simply we multiply this thing. 6.91. This is the 6.9075. I have taken the wrong. Exactly the same. Minus 6.9095. That means around after 3 decimals, which cannot consider. So is exactly the same. And here age is the, if you multiply the 10.418, 10.418, this one will be 0.0291. 2091. Zero 0.21786 is exactly the same, right? And here significant codes which you already dispersion parameter. See, we are building the model, we are building the probability. Here we are the two cases we got it, yes or no case. Let's say in our case our dependent variable is bot. That means we have a 2, 0 and 1. In the 0 and 1 means, which indicates 1 means buying the product, 0 means not buying the product. Whether we will get the probability values. Let's say for the first record I got the probability value 90%. Now I said 90% probability customer, the first record, first X, assume that X is the first customer, and let's say A is the first customer. A, there is a 90% probability chances A is going to buy the product. Let's say we have the first record A, B, C, D. This assume that customer ID. A probability value got the 90%, B probability value 70%, C probability value is 30%, D probability value is 10%. Like this we have assume that. Here I said that 90% probability 90% probability a customer will buy the product. I said 90% probability, 90% of probability a customer will buy the product. You may get that. Why we are saying 90% a customer will buy the product? Why don't we think 90% of the chances a customer will not buy the product? Why don't you think 90% of chances, 90% of the probability a customer will not buy the product? First scenario I said 90% probability a customer will buy the product. In the second scenario I said that 90% of the probability a customer will not buy the product. Both cases are the true. Then how do you assess that which one is the correct? Does my statement one is correct or does my second statement is correct? How do you assess it? To assess that, here we are going to use dispersion parameter. That means binomial family taken to be it building the probability value. It building the probability value for the 1. 1 means by the customer, 0 means not by the customer. So always while building the model, make sure that whatever you are going to build, it is taking the model as 1 only. For example, you may get that doubt. Okay, let me done with this. I will okay. Let me before we are going further. What happens if I mention the family is equal to binomial? If we mention family is equal to binomial, it always build the model for 1. If we mention family is equal to binomial, it always builds the model for 1. 1 means in the dependent variable 1 category. It will say 1, whatever the 1. For example, 1 says not buying, so 90% of chances they are not buying the product. What happens if I did not mention the family is equal to binomial? What happens if we did not mention the family is equal to binomial? Let me give an example. Here I am removing the family is equal to binomial. It will build what is happening here. See, dispersion parameter for Gaussian. Gaussian is the normal distribution. Normal distribution means again is a linear model. If you are not mentioning the family is equal to binomial, it does not building the logistic regression. It is building again the simple linear regression. Even it is taking the building the model for 0.03. It doesn't correct. Always you need to mention the family is equal to binomial. Next, null deviance means what is the error of the independent variables? Null deviance means variance error of the independent variables. The formula is n-1. n-1 means N is the number of observation minus 1 is the dependent variable. So if you want to get the only one dependent variable is there in our model, so remaining all are the independent variables. The formula is n minus 1. So here number of observations are how many? 467. So minus 1 means 466. Here the error deviance is variance error deviation is deviation means error basically. Null deviance means all the independent error deviation. That is first. Residual deviation means error basically n minus k minus 1. AIC means residual deviance means error of the standard error. Error of the standard error. Error of the standard error. That means mu by sigma, again the formula of the error variable. Error means actual value minus predicted value into mu by sigma. This is the formula for the mu is nothing but mean value, sigma is nothing but standard deviation. Mu is nothing but mean value, sigma is nothing but standard deviation. Sigma means standard deviation value. Again the formula is same, like the with n minus k minus 1. N is the number of observation, k is the independent variables, 1 is the one dependent variable. Here in our case n minus k minus 1, let me write down like this. N minus k minus 1. N is the number of observations, k is the independent n minus k minus 1. N is the number of observation, k is the independent variable, 1 is the one dependent variable. Okay, here that is the 465. AIC means Akai information criteria. Akai information criteria. This means how much amount of information we are losing from this model. Standalone AIC does not make sense. When we are building the multiple models, we can use AIC wherever it is less. We can use the when we are building the multiple models, we can use the AIC values wherever is less. How much amount of information, how much amount of information we are losing from this model. Standalone AIC does not make sense. When we are building the multiple models, we can use the AIC value whenever is less. The formula for the AIC is AIC formula is minus 2 log 2 k, minus 2 into log 2 k. Log 2 means base 2, k means independent variables. K means independent variables. Minus 2 into log 2 k. K means independent variable. The formula is minus 2 into log 2 k. In our case, minus 2 into log 2 1. Right? Based on this one, we get the this, and Fisher is the scientist who found the logistic regression. Based on this iteration, to get these values internally, it ran the 7 iterations. This is the meaning of all this thing. Again, we will discuss this one on Monday.